Okay, next topic. Let's talk about the surfaces and the filtration properties. And first, we want to start with this. You know, we have two types of AFMs. Until 2-3 years ago, we only had our AFM and nothing else. And since 2 years, we have now AFM NG, and NG stands for
next generation.
Next generation. So yeah, this is like with the iPhone, each version gets better, right? And this is why we call now our old AFM standard, which is fantastic, a brilliant filter media, and AFM NG, the next generation, which is even better. And the better is the enemy of the good. What do they have in common? They have in common both that they have the self-sterilizing surface. Both of them are bioresistant, and both of them have a completely increased surface. I pass this now to you because my colleagues always say you take all the lead.
You like to talk, everybody likes to talk here, so we try to balance that at least as best as possible. Coming back to our difference here to other medias, but which is same for the AFM standard and the AFM NG. So here we have the high surface area. What that means, this looks like a little bit like the Swiss Alps. But that's maybe also important because on all of these surfaces, we generate these free radicals. That's why we have this very beneficial performance of not only having a self-sterilizing, but also a superior mechanical filtration performance down to 1 micron. We'll show you in the next slide. But more important here is we let me
clarify this, you know, because that was maybe a little bit fast. So the increased surface has two consequences. Much better filtration performance and much more bioresistance.
Exactly, yes, thank you. Okay, coming to the mechanical properties, we are not doing absorption. We really only do adsorption on the surface, means in this case, all the particles are adsorbed on the surface area and easily backwashed, removed from the media during a backwash process.
What's the difference to absorption? What is an example for absorption?
Okay, let's take an absorption. I mean, most of you who are here, they know activated carbon. Activated carbon is a perfect example for absorption. So you have a lot of mesopores, long, deep channels where these bacteria or small particles, they go into, attach to it. The problem is they are not removed. So that means they work perfectly at the beginning of a filtration process, 1 week, 2 weeks, maybe 2-3 months. But suddenly after a couple of months, they don't work, they start to have biological growth, and then they don't work anymore as they have promised by the suppliers.
No, I think
so
we don't want to blame it at all.
In a way.
It's saturated, yeah, it builds up biofilm, and then, there is end of lifetime, you know, and I mean, honestly, I mean, with activated carbon, you can do a few things that we cannot do. So we also work using our process activated carbon. It's not to blame carbon. It's just to say this is a fantastic filter media, but it's absorption, and that means you have to replace it. Or if you take zeolite, it's the same thing. You know, it's very huge in the surface, fantastic for absorption, but it has to be regenerated in a very
you can do this, but it's
a difficult process.
It's labor intensive, and you can only do it a few times.
So here we really same as with activated carbon. You also can reactivate it. We don't need this with AFM. You just make a decent backwash, and then you can keep the product for many, many years.
Yeah, we don't talk about chemical removal here. Really, we talk about mechanical filtration properties.
Okay. So that's what both products have in common, huh?
Yep.
These two things.
So, Philip, you want to take this?
So what's one thing that's unique for AFM standard now, right? Yeah. That's unique to AFM standard is that AFM standard has the activation chemicals that we apply to it give AFM a negative surface charge. A
very high negative surface charge that you see here.
So this makes AFM standard very good at attracting positively charged particles. For example, and this is the main application where we use AFM standard today. It's in the reduction in the filtration of heavy metals, iron, manganese, arsenic that are precipitated.
Yeah, exactly. So again, to clarify it, you know, AFM standard is a great product, fantastic product We just have now a better one, the NG, for most of application. One of application where AFM standard is better is heavy metal removal. If you're in this field, please join us. AFM NG, the better is the enemy of the good. You know, Howard has developed this to remove microplastic. I mean, AFM standard is not perfect in removing microplastic if you don't add coagulation, flocculation. So he wanted to develop something which is a non-polar, which has no charge, which is hydrophobic, and which can really remove microplastics. Howard today is not anymore that active. I mean, he's always available and helps us, but he passed his role as the chief technical officer to his son, Matthew. Brilliant guy, brilliant man. So we have all his support, but Howard's focus today is on GOES, on the GOES Foundation. You want to say a few words to the GOES Foundation?
Yeah, I mean, this is a foundation that he started to drive, initiatives to improve, the health and the quality of our oceans, basically. He's very much concerned about that. I think we all are concerned about pollution of our oceans. And so this is what Howard is doing now.
Yeah. So to keep it short, he says, well, the biggest problem is that we have in the ocean. If we lose the ocean, we lose the planet. Yeah. You know, it's the base of our life. Yeah. And one of the big problems are microplastic that we have in our drinking water, that we have in our wastewater, that we have in the oceans. Why? Because on the microplastics, you coagulate, you concentrate all the toxic chemicals, and then they come in high concentrations and move up the food chain. So from the plankton to, and especially the plankton, fish, yes. You know, we lost 40% of the plankton in the ocean. So in the last 70 years, this is a problem. Yeah. And this is why we really should avoid microplastic or filter them out. Now, how do you filter microplastics? You do this because they're hydrophobic. They don't like water. You have to use a hydrophobic filter media, such as activated carbon or AFM NG. And when we had it, you know, we also found out when we tested, this is great for microplastic, you know, it's amazingly great, but also for other organics, exactly. Or for organics, proteins, oils, lipids. Mm-hmm. And we found out it's even better than AFM. And yeah,
I mean, here very important is like in water treatment, let's say seawater desalination processes, there's a lot of oil hydrocarbons in some of the open intake seawaters. We can remove that oil with our filter media together with the perfect high filtration of particles, and we can really achieve super clean water after our filtration process.
Yeah. Roger, I cannot, I don't have any more control. No, thanks, okay. I have. So it's very good for this. Let's explain maybe a little bit hydrophobic, hydrophilic. Philip, you want to take this?
Yeah, okay. So we were talking about AFM standard which is a hydrophilic media, which means it loves water. It allows hydrogen bonds to happen. And hydrophilic molecules like other hydrophilic molecules. It's like humans, you know, some like this and some like the other, right? On the other side, we have AFM-NG, and it was mentioned AFM-NG has a hydrophobic surface, which means it repels water, and hydrophobic substances like each other, right? So this is why AFM-NG with its hydrophobic surface is very good at filtering out other hydrophobic substances, such like hydrocarbons or microplastics.
Yeah.
Yeah, and here on this small video, we can easily explain you. On top, you see AFM standard, hydrophilic. Below you have AFM-NG, hydrophobic. You see, this is a super hydrophobic. You will not get it that hydrophobic, but you clearly see the difference, you know, and that also is, you know, when we started, people said, well, Dominic and Philip, you're nice guys, but I think you're marketing guys. There is just marketing, you know, where is the activation? Can you prove it? And you can, but it's quite a difficult process with AFM standard. You have AFM-NG, it's very simple, you know, very simple, you can show it. So all clear, AFM standard, AFM-NG.
Maybe to mention that it's not floating, as even if it's hydrophobic, it's not floating. So we have really control over the production process. So that works perfectly as a filter media.
Yeah, We also write this in our manual. You know, you have to treat it a little bit like activated carbon. You should put it in water and leave it there for 24 hours before you make your first backwash, because the first few hours, few particles are floating.
Yes.
And it's also normal that there is a little bit of fines in that you will lose in the first 2-3 backwashes. That's kind of normal. They might be also, you know, also I mentioned before in the washing process that we reduce the organics from 50,000 that the raw glass has to 5,000. Then in the full process crushing, you know, where we always suck and blow the contaminants out of it and the activation, etc., we bring it down to 5 grams organic. So in 1 ton of AFM, 5 grams organic, mainly paper. Mainly paper, but it's nothing. And also this, you might have a little bit on the filter bed of the first,
second backwash.
Yeah, absolutely. But to summarize, you know, in this activation process, we decide, do we make AFM standard, high negative surface charge, or we do it AFM NG, hydrophobic. This for most of application, organic removal, this especially for heavy metals.